to the last part of our lesson today, which is on quadratic factor, form of partial fractions in quadratic factor, which is part 3. Alright, so we have these examples here, which you look at on this example. If you look at the denominator, shows that there's x squared in the bracket. So what does it mean? It means that is the denominator for this fraction is actually in terms of quadratic. So what can we do with the quadratic factors in the partial fraction? So we have to, same thing, we have to decompose them into its partial fractions. So you see this is repeated, this is x is considered as a linear, and x squared means it is a repeated linear, right? So we have a over x plus b over x squared. This is repeated linear, remember? Plus, and this is quadratic factor, so cx plus d over x squared plus 3. That is one factor, is one factor, that's one factor. That. So first thing first, you have to find the denominator. If you want to solve this fraction, find the denominator. What is the denominator for this? So it has to be x squared plus 3. Yeah. So you can divide by this, you can divide by this, you can divide by this. Alright. So this term divided by x, you will have a, which is x squared divided by x, become ax, only one x there, and then you will have x squared plus 3 plus this one divided by this will become b x squared plus 3 plus this one divided by this, this one we have cx plus d, and you left out with x squared, right? X squared is still there. So you have is equivalent to a, we can write them back, that one is x squared plus 3 plus b x squared plus 3 plus cx plus d x squared, right? So this top form here, it will be just maintain 3 plus 6x plus 4x squared minus 2x. Alright, now we have this as our equation 1. You can see this equation 1. Alright, and then we're going to solve that by one. Remember, when we have to put the value of x, what are the values of x? So in this case, is x when only 1, which is, we can say that when x equal to 0, yeah? When x equal to 0, we just put the value of 0 here. 3 plus 0 minus 2 times 0 becomes, this one is 0, 0, 0, and 3 is equal to, this one becomes 0, this one 0, this one is 0. We have to, before that we have to extend this first, right? Before we get that, we will extend this, become ax, expand this, become ax cubed plus 3ax plus bx squared plus 3b plus cx cubed plus dx squared. So we have expand this, right? So this one still the same, 3 plus 6x plus x squared minus 2x cubed. So we have this one as our expansion of this equation number 1 there. Alright? So we have the x squared, the x. Okay, let's have a look at when this is the one factor here, when x equal to 0. We're going to put 0 here and 0 here and 0 here. So this one becomes 3 is equivalent or equal to, so there's no more equivalent. This is 0, 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 so become 3b, so b become 1. So there's 1 there. B is equal to 1. We have that. And then let's find the value of B, C, A, B, C, and D. So from this we have, let's have a look at the term x cubed. X cubed, that's 1, that's 2. How many x cubed? There's 1, 2, there's another one there. So there's 1, 2, 3 x cubed. So it's negative 2. X cubed is negative 2. So meaning that is negative 2 is equal to A plus C. We have another expression there, which is we don't know what is A, what is EC yet. We don't know yet. So we have one expression there. Let's look at another term, which is x squared, and this is x squared. So 4x squared, 4 is equal to 3 plus d, right? So you can say that 4 is equivalent to 3 plus d. Do we know any of the value yet? We have known 1, we have known b, we have known no. Yeah, we can know, we can actually, there's 1 there, one equation, this is equation, another equation, and this equation we can solve for d. So d is equal to 4 minus 3, which is 1. So we have found d is equal to 1. And then what about next term, x term? 6x here, let's put it in this form. 6x is 3ax, and yeah, and only that. 6x is 3ax, right? So we can find that 6 is equivalent to 3x, 3a, right? So a equal to 2, right? 6 divided by 2, you have another one, which is a equal to 2. There's 1 there. You have found b, find c, and you can find in a, you can find c. So use this, and you get negative 2 plus 2. Negative 2 is equal to 2 plus c. So c is equal to negative 4, right? So you have A, you have B, you have C, and you have D, right? So let's put it back inside this equation. So 3 plus 6x plus 4x squared minus 2x cubed divided by x squared plus 3 is equivalent to, what is A? A is 2. 2 over x plus what is B? B is 1 over x squared plus what is C? What is C? C is negative 4. We have negative 4 x plus what is D? D is 1 plus 1 divided by x squared plus 3. You have that is your value of A, B, C, and that's A, B, that is C, and that is D. So this will be your answer. Let's have a look at that. Is it right? Yeah, 2, 1, 2, 1, and 4x. Oh, this one become 3. How would you get 3? 3, 3, 3. t is t, 4 is b plus d, 4 is b plus d. Oh, this is b, yeah? It's not 3, it's b plus d. So d is actually 4 is b plus d, so you know b, d become, when you know b, 1 plus d, which is 4 minus 1, 4 minus 1, and d is 3. Yes, we can change that. So d becomes, okay. So thank you very much, and that is all for our partial fraction. And remember that if you look at on an exercise of the notes that I give you, if you look at on the same, have a look at partial fraction with the same degree as numerator, right? Partial fraction with same degree as numerator. So let's say, for example, that you have x squared plus 1 divided by x squared minus 3x plus 2. So you can see here the numerator and denominator actually have the same value.